Hi everybody, and welcome to Data Viz-Sanity 2024, the first annual competition where we put AIs against each other in a no-holds-barred tournament to see who can solve the most difficult problems in the most elegant way with the least prompting from me. Wow! We have some of the most famous AI programs in the world from the biggest companies ready to go. Our brackets look like this. Number 1 seed Claude versus number 8 seed Meta AI. Number 2 seed Perplexity versus number 7 seed U.com. Number 3 seed Google Gemini versus number 6 seed Amazon Chatbot. And number 4 seed ChatGPT versus number 5 seed Copilot. Over 3 knockout rounds, I'll be asking these AI programs to solve a problem for me and visualize their solution. They'll be judged on how well they understood the problem without extra explanation, how well they solved the problem, and how well their visualizations conform to my 5 basic principles. I'll be sharing my solution, or the correct solution, in a video right now, and then sharing the head-to-head matches between the different AI programs over 3 rounds until we get to only one winner. So without further ado, let's introduce today's problem, the glass panels game. For this one, we're headed back in time to Squid Game Season 1, Episode 7. The remaining contestants were put on one side of the room and had to cross a series of glass panels to get to the other side. The problem: contestants had to choose one of 2 glass panels at each step, one of which would not support their weight and would watch them fall to their death, while the other would hold them and let them go again. Some key things to be aware of and assumptions we're going to make for this game. First, each player has a 50-50 chance of picking the right pane of glass at each step. 2. Subsequent players learn from the previous players whether they pick the correct pane or the one that breaks. They will all have a perfect memory and never fall through one once we know what the right answer is. 3. There are 18 panels, 16 players. 4. We're going to ignore the time limit from the TV show because modeling that adds too much complexity to the scenario. Players will also stay in order and only die one at a time. So Zhang Duxu doesn't get to force people out of order, Han Minyo doesn't get to pull him down with her at the same time, none of the extra excitement and drama that happened in the actual show. There's enough drama knowing that there's data viz here. Lastly, no one has any information on future panels and knowing whether the glass is tempered or not. I'll walk through my solution before we start the competition. There are other ways of doing this that arrive at the same answer, and we'll see some interesting different approaches from the AIs as we go, but this is how I chose to solve it. It's how my brain works, yours may vary. A side note, my best introduction to probability and stats came from a class I took at Harvard under Dr. Gary King, who at the time was one of the top methodologists in political science. He taught me that humans are really bad at understanding probability, and a great way to calculate probabilities is to just create a scenario in the programming language of your choice, simulate it a bunch of times, and see what the results of the simulations tell you. So that's how I approach this problem. We can calculate it traditionally using the binomial distribution, but at least the first few AIs I spoke to made some ridiculous assumptions to avoid actually calculating it, so I'm happy with my choice. That's enough of the side note, let's get back to the auditorium. So first, what I'm going to do is create a function called player_moves. It will need the user to provide the value runs, which will just be the number of simulations you want to run. I'm eventually going to want a vector of players and a vector of tiles to store the counters for each run, or how many players have gone / how many tiles have been revealed. So I'll initialize those right now as blank vectors where things will be saved later. Easy enough. What's next? Well, I always like a good for loop to do my sims. Meemaw used to tell me, whenever you want to run simulations in R, just start with for I in 1 : runs. So there we are. Next, we initialize the counters for players at 1 and tiles at 0, and because we're going to draw a random number of 1 or 0 later, we'll need to start a vector to store the random numbers we draw, so we'll create that here. Easy enough. We've created the beginning of our loops. Now we need to actually do the work. So we're preparing our counter. While players are less than 16 and tiles are less than 18, we'll keep simulating player turns until either 16 players die or they cross 18 tiles. Each move will be chosen as a random sample of a vector of 0 or 1 with replacement because each move has a chance of being survive or fall. We'll take that result and add it to the vector of random numbers we initialized as empty earlier. This is the key step right here, and one AI seems to struggle to understand. Each move will increment the number of tiles by 1 because whether the person survives or falls, we gain information on that tile. If they fall through, we know the other tile is the safe one. If they land on the safe one, we know that tile is the safe one. But no matter what, as long as a person takes a turn, we learn something. And remember, one of our assumptions is perfect memory. Mathematically, we express this by adding 1 to the counter every turn. The final step here is that players equals the number of players who have fallen through the glass panels. We represent this by incrementing the number of players by 1 each time someone draws a 0, which is the number we selected for fall. Some final housekeeping here. We add the final number of players to the players vector, so we can have that for later, and then tiles vector stores the number of tiles they completed. This is probably unnecessary because intuition tells us the odds of no one completing this game is virtually 0, but I put it in without thinking about that, so it's there, we're gonna leave it. What are you gonna do? Finally, I ask R to return the player's vector we calculated in this function as the final output, which we will use to see the results later. Okay, so this got into the weeds a little bit here. So let's take a minute to do the too long didn't read and talk through it in regular people words. We want to simulate the glass panels game, so we need to see when 16 players will complete jumping across 18 rows of panels. If a player falls, then they are eliminated, and we learn what they should have chosen. If a player succeeds, we know they chose the right one, and they go again. The game only ends when we run out of players, 16 failures, basically all in a row, or panels, 18 successes before 16 people fall. The script walks through this using some overly complex formulas and functions, but that's basically what you're doing. The simulation draws numbers that match that intuition and goes through that logic, does so as many times as you would like it to. There's a lot of code around that, but it's the basic idea. The lesson you should learn here is to think problems through in their components. If you're not an expert level programmer but can do this, AI can help you with the coding. But as we'll find out through the tournament, AI will not solve these problems for you correctly. It needs your support and understanding of the problem, so you at least need to learn to pseudocode and think through these types of problems in human language. That's enough for this side note, but I want to make sure people understand the importance of being a good prompt engineer rather than just asking questions of AI, treating the answer as gospel. This, for many people, will actually be a more useful skill than being an expert in coding. So let's go back to the main stage. Once we've created our function, we just need to run it, so let's do that. We'll run the function 10,000 times because that seems like enough simulations but won't take too long. The law of large numbers should kick in enough for our purposes by then. We'll store the results in a vector called test_results. Our code here is test_results, the arrow to store it, player_moves, parentheses, runs, equals 10,000. So once that's run, we need to table the results, calculate the proportion, and turn that all into a data frame for R to use later. We do that with data frame, parentheses, prop.table, parentheses, table, parentheses, test_results, and then a whole lot of end parentheses. These next lines add a row of 1 with 0 frequency because the odds of the first person completing the game is virtually 0. They probably didn't show up in our sims, and we want to make sure that R has it in there when we start to graph and doesn't weirdly start the graph at 2. There's certainly other ways to do this, but I figured this is the way I would do it, so please don't judge. So here's the results of all we just did. Very cool, right? A quick scan shows the likelihood of survival starts growing at around 6 people, and keeps growing substantially until about 12 or so. Very cool. But as we know from my How Not to Visualize Data playlist or my course on data analysis and Viz, tables are not the best way of showing data ever. I was going to say they're the worst, but I thought people would comment ways that are worse. Wait a minute. Comments will help me bump my video in the algorithm, so yeah, they're the worst. If you think I'm stupid and wrong, make sure you tell me in the comments. That'll show me. Did you comment yet? Did you hit like and subscribe? If not, while you do that, I'm going to take a couple minutes to remind everyone of my 5 key rules of data visualization. Number 1, be simple in your presentation. The goal is to communicate, so doing a fancy graph people don't understand immediately because you want to show off your fancy skills is just pretentious. This is controversial, I know, but there's rarely a reason to use anything other than a bar graph, a line graph, or a scatter plot / bubble chart. Number 2, be honest with your presentation of data. Don't use misleading axes or spacing to make a point look more pronounced. Number 3, what do you want the reader's primary takeaway to be from this graph? Use the title, color, anything else at your disposal to help guide readers to the primary takeaway, while using principles number 1 and 2 as a guardrail. Graphs should be self-contained. That is to say, I shouldn't need text in an article to understand your graph, especially in a world of social media where only pictures get passed around and no one really reads articles anymore. Label your graph clearly, label your axes, describe your data set, do all the things you can to make sure everyone knows what they need to know just by looking at your graph. Finally, keep it simple, eliminate chart junk. Always going back to that potentially apocryphal quote from Coco Chanel, before you leave the house, you should look in the mirror and remove one item. I fully believe she meant this about fashion, but also meant it about data visualization. Not only will we be following these rules as we go, but we're going to judge the AI output based on these rules, so it's good to remind us of what they are. Time to go back to the Dr. Chad Auditorium with you having liked, subscribed, and commented on this video. So, my interns here have been working hard backstage, graphing away, getting ready to show these data in the ideal way. Let's see what they've done. Okay, the team gave me a really nice graph here. There's a lot to like about this, and it meets all of my 5 basic rules. Number 1, it's a bar graph, which is simple, clear, and easy to understand. 2, there's nothing misleading about this. 3, the title isn't super informative, but that brings up a question of how informative the data viz is itself. I do like they made it Squid Game pink with a black outline. It's a nice way of evoking memories of the show, letting people know what the viz is about. 4, the graph is self-contained. It doesn't really need any other explanation. And 5, there's no real chart junk here. It's super simple, Coco Chanel will be proud of us, and that's all that really matters. This is a bit of a side drain, but I'm comforted by the data viz showing my intuition on what the results would be. Virtually none of the early players would survive. It would peak around 10 or 11, because you expect each player to get through 1.5 panels, and something resembling a normal distribution. Everything looks good here, so I'm feeling pretty good about my script getting it right. Meemaw used to tell me, whenever you simulate events in R, make sure results fit your intuition. Classic Meemaw. One other side note, I did run this through a couple calculators as a binomial probability problem, and this matches their results, which adds to my confidence. This is going to be important later, but enough foreshadowing, let's get back to the main stage. I do want to call out, I'm a bit stuck on point number 3 though. The title isn't super informative here, and I don't have a great way to make it more informative. The interns did their job, but I think this is about what they can do. It's something I hadn't considered, and I think it highlights that there are opportunities to improve this graph. My team is typing away backstage, testing another option that I think we'll like better, so let's see what they did. Okay, what they did here was take the cumulative sum of the frequency variable and graph that. Basically, player 1's odds of survival are the odds of player 1 surviving. Player 2's odds are the sum of player 1 and player 2 surviving. Player 3's odds are the sums of players 1, 2, and 3. And all the way to player 16, who has the cumulative sum of all the previous players surviving plus their own, which, as you can see, goes about to 100%. This is much more informative and meets all of our rules we talked about earlier. But most importantly, it tells a key story. If I'm a player and knew the game ahead of time, I'd obviously want as low a number as possible. But looking at this, you'd probably be confident in around player 12, player 13. Those have a pretty high chance at survival, especially given that we're in the Squid Game. If I'm the front man, I might look at this and have an optimal number of players I want to make it to the last round, and this could help guide that. Maybe I want 4-ish players to make it to the final round. But if you look, half the time, somewhere around 6 or 7 survive. How can I manipulate the rules and get that number down to 4? Well, one way might be add a time limit to reduce player 15 and player 16's chances of surviving. Maybe there's other ways, but that's what they decided in the show, so we'll just go with that as the final product recommendation here. I think this is the one. I don't think we can really improve over this, so this will be the data viz we judge all the AI vizes against. Maybe someone will do better, maybe one of them will surprise me, but I doubt it because I am literally a professional at this, and AI is just the sum of all human knowledge. Okay, I'm less confident now, but that's why we do Data Viz-Sanity here at the Dr. Chad Auditorium. See you for round 1 up next.